Hello everyone, I'm Jane. Today I'm going to present our paper, Retrieval-based neural source code summarization. This is the outline. First, as we all know, a code file mainly includes source code and its summaries or comments. Developers write code summaries based on the code. The source code summarization is a technology for generating summaries. Summaries are very useful for understanding and maintaining source code. Developers often spend a lot of time on reading and comprehending programs. However, in reality, well-commented projects are few, which incur more maintenance costs. So it's important to explore automatic techniques. There are two types of existing techniques, IR-based and NMT-based ones. Early studies paid much attention to IR-based methods, including VSM and ISI. Based on them, for example, given the code shown in left, they extract keywords or search similar code and reuse its summary. Recent work shows that NMT-based methods are promising and outperform IR-based ones. The typical architecture is the encoder-decoder, which includes an LSTM for encoding code snippets into context vector and another LSTM for decoding and generating a summary. But there are also limitations in NMT models. A recent study on commit message generation found that a very simple retrieval-based method can outperform a carefully designed NMT model. It points out that NMT tends to generate common patterns. Besides, in the NMT community, it's also revealed that NMT model is comparatively weak in generating infrequent n-grams. Further, in our datasets, the statistics shows that nearly 80% summaries contain low-frequency words. The next part is our approach to the problem. First, we investigate a Python method case to compare IR and NMT. We can see that IR-based summaries contain the low-frequency word IIS, but NMT can't generate. Even so, NMT-based summary is more flexible and semantically correct. For example, it doesn't generate noises like a remove or virtual directory, as IR does. So why not combine them to generate a better summary? The truth is that it's much harder than it sounds. First, we must know when the decoder needs to generate a low-frequency word. Second, what should the decoder generate? If a low-frequency word is needed, it will simply generate all low-frequency words. Then there will be much noise, and thus the quality will be very poor. In this paper, we propose our solution to realize it. The basic idea is to augment NMT model with retrieved knowledge according to the similarity and the conditional probability, so that let NMT model know if it should generate a low-frequency word at each time. This is a detailed framework. It includes an attentional encoder-decoder model, similar code retrieval, and the retrieval-based neural summary generation. I omit the details of NMT in this part because it's already introduced before. There is a syntactic level and a semantic level retrieval. We represent the code as ECD-based token sequence and use Lucerne to efficiently retrieve most similar code from the training set. For the semantic level, we reuse the trained encoder and max pooling to obtain a single vector from the code. Then we compute the cosine similarity to retrieve another similar code from the training set. This is our retrieval-based neural summary generator. It encodes each test code and its most similar ones simultaneously, gets their context vectors with attention mechanism. Here we denote these conditional probabilities by p-test, psin, and psen. Then we calculate and normalize the similarities to make the two codes comparable based on the tested edited distances with dynamic programming. We also add a lambda as a hyperparameter that can be manually tuned. Based on the final conditional distributions above, we can generate the whole summary sentence word by word. About the evaluation. This is the experiment data in Python and Java. The bottom table is the statistics about the two datasets. It's obvious that there are many low-frequency words in both of them. I present two key research questions in this part. The first is about the performance of our approach. From the first group in Table 1, we can conclude that retrieval-based methods yield good results, and this indicates there does exist similar code in the training set. Next is the NMT-based group. Their performances vary a lot according to the evaluation metrics, and obviously code NN performs worse because it only depends on the embeddings of tokens to understand the semantics of code snippets, while other methods incorporating API and AST knowledge. Finally, we can see that our approach achieves the best performance in terms of all evaluation metrics. This attributes to the combination of similar contexts with NMT model and proves that our approach is superior to the GRNMT from NLP community. We studied the effectiveness of our approach from two aspects. First, we study the effectiveness of each component in it. By comparison, we can see that the performance improves a lot when adding retrieval knowledge. Next, we perform a statistical analysis about the low-frequency words in generated summaries. From the table, we can see that our approach can correctly predict more low-frequency words than NMT when the word frequency is small, for example, less than 10. Obviously, these additional low-frequency words come from the summaries of our retrieved code snippets, which validates the effectiveness of our architecture. We also perform human evaluation, and the results confirm the effectiveness of our approach. To conclude, first, NMT-based methods are feasible for source code summarization, but they also have natural drawbacks, such as the low-frequency word problem emphasized in our paper. So the next conclusion is, our retrieval-based neural approach is effective for mitigating the problem and thus enhances the performance. However, this does not mean the problem has been completely solved because the overall performance is still not satisfactory. In the future, we recommend researchers to pay more attention to neural source code summarization to find and solve various bottlenecks. Thank you.